Hello everyone and welcome to my channel. Today we are diving into Bash, a classic and really fun beginner level machine from Hack the Box. This box is perfect for learning a fundamental penetration testing workflow, from reconnaissance and web enumeration to getting a hold and then escalating our privileges not once but twice to become root. If you're studying for the OSCP or just want to sharpen your skills, this is the walkthrough for you. We're going to break down every step and, more importantly, explain the why behind every command we run. So let's connect to the VPN and get started. Sudo open VPN and we see initialization sequence completed. That's our green light. We are on the network and ready to find our target. Before I start any box, I like to get organized. I used a simple bash script to set up a teamwork session, which gives us 4 panes. Alright, let's kick off our reconnaissance with the most essential tool in our arsenal, Nmap. We'll start with a full TCP port scan to see what services are running on the machine. The command is sudo nmap and our target machine. Just type this. So I've just ran the sudo nmap and so -p- tells nmap to scan all 65,535 TCP ports, not just the common ones. We don't want to miss anything. -sc, -sv are for script scanning and version detection. This tries to figure out exactly what software is running on the open port. -pn skips the ping check, which is useful if a host blocked ping. -n This option disables DNS resolution, which can speed up the scan by not attempting to resolve the target IP address to a host name. And T5 makes the scan run aggressively fast. -OA disables the output of the scan in all available formats, with the file name prefix TCP scan. So we should wait for this. And here are the results. We've got one port open, port 80, running on Apache web server. The title of the page is RxL's development site. We should definitely remember RxL as a potential username. Okay, so we have a web server. This is our front door. For that, we need to do web enumeration. And that brings us to our next tool, Gobuster. So, why use Gobuster right now? Because web developers often leave behind hidden directories, backup files, or admin panels that aren't linked from the main page. Gobuster helps us find this by brute forcing a list of common names. We are going to use a powerful word list from setlist, which you can install with a simple sudo apt install setlist. Sudo I've already installed, so let's check the Gobuster command. First, we call Gobuster and tell it we are running in dir mode, which is for finding directories and files. Next, the most important part, we have to tell it what to attack. The -u flag is for the URL, pretty simple. Now, how does Gobuster get the directory names? It uses a word list. The -w flag points to our list. We are using a fantastic medium-sized list from a collection called setlist. This gives us thousands of common names to try without taking forever. By default, Gobuster is a bit slow. You can speed it up dramatically with the -t blackbird thread. Think of this like opening 50 browser tabs at once to check pages instead of doing it one by one. -t50 is a nice aggressive speed. The next flag tells Gobuster to not only look for directories, but to also check for files with these specific extensions. So for every word like admin, it's going to check for admin.php, admin.txt, admin.bak. This is how you find hidden login pages or source code backups. And finally, we don't want to lose these results. The -o flag tells Gobuster to save all the output to a file, in this case gobuster.txt, so we can review it later. Okay, the command is ready. Let's run it and see what hidden treasures we can find. You're telling Gobuster to check for directories and also for files with common extensions like .php and .html. So notice the status 301. That just means it found a directory and is redirecting us to the proper URL with a trailing slash. It's a confirmed find. 301 means moved permanently. The most common reason you see this when brute forcing directories is that the server requires a trailing slash at the end of a directory name. And one of these look very interesting, a dev directory. That sounds like a place developers would work. Let's check that out in the browser. Navigating to the dev directory, and we find two files, phpbash.php and php.min.php. This is a well-known tool. It's a web shell. This is our way in. And just like that, we have a shell on the machine. After running whoami, we are running as the www-data user. This is our initial foothold. Now that we are in, the next phase is local enumeration. We need to find a way to escalate our privileges from the low privilege www-data user. One of the very first commands to run in this situation is sudo -l. And look at this is a golden ticket. The output shows that our user www-data can run any command as the user script manager with no password. So when you check this, so can run as the user script manager with no password or comments. This is a clear path to our first privilege escalation. So before we start privilege escalation, we will focus on retrieving flag for normal user, running as the www-data user, cause we are www-data user now. Why is it crashing? This is our initial foothold. Before we even think about escalating our privileges, the first thing we should do is look for the user flag. This is standard practice in Hack the Box. So we'll navigate to the root directory. cd home. So two user directories, RxL and script manager. Does RxL sound familiar? It should. That was the name we saw in the Nmap scan on the website's title, RxL's development site. This is a great example of how clues from early enumeration pay off later. It's almost certain the user flag will be in this directory. Let's see if our current user www-data has permission to look inside. So we can enter this and read the contents of the user.txt, and there's our user flag. So awesome. So we will also copy and paste here. Before we can also copy and paste here. And the comment we have done is from now on, let's try to become script manager. The standard command would be sudo -i-use script manager. But watch when I run this. Sudo -i-use script. But nothing happens. So why did it fail? And why do we need a reverse shell now? This is failed because our current web shell is a dumb shell. It's not a real interactive terminal or TTY. The -i flag in our sudo command specifically requests an interactive login, which our dumb shell cannot provide. So it hangs. The solution is to bypass this problem entirely. Instead of trying to upgrade our current shell, we will use our sudo privilege to execute a command that gives us a brand new separate shell, a reverse shell as the script manager user. Python one-liner reverse shell script later will create a new separate shell and connect it back to you. Requires only the ability to run Python and make outbound network connections. So first we have already started the listener with port 4444. So we are going to run the reverse shell on the target machine. So before executing this is the command. So let's investigate this command. As socket. First of all, socket is the networking library. It's what lets us create the connection, the telephone itself. Subprocess is the library that lets us run other programs like the shell we want to launch. And OS is the operating system library, which gives us powerful low-level control which we'll need for our magic trick in a moment. So next, these lines. First of all, these lines create a standard network socket. You can just think of this as creating the physical telephone. AF_INAP means we are using a standard IPv4 address, and SOC_stream means it's a reliable TCP connection, just like a phone call where you know the other person is on the line. As .connect, and this our local host and listener. and this line dials the number. This is the exact moment the target machine reaches out across the network and establishes a connection with our waiting naked listener. So the next comment, it's like when we can I can give you the metaphor with this command. So when you move, you go to the post office and fill out a change of address form. You tell them, hey, any mail that was supposed to go to my old address, I want you to send it to my new address instead. The post office then redirects everything for you. That is exactly what we are about to do here. The post office is a Linux operating system. The change of address form is our OSCP command, and the old addresses are the keyboard, which means file descriptor 0, and screen, file descriptor 1, and standard error log, file descriptor 2. The new address is our network connection back to our attacker machine, which is our local host. Now that all the plumbing is redirected, the final step is simple. We just need to start a program. This command runs a new program bin sh with the -i flag, which tells it to be interactive. So before of the previous step, this new shell is born in a special state. And it's actually taking directly to our netcat listener over the network, giving us full remote control. So let's run this command and check our netcat. Where am I? We can enter this now. So we can go to the home folder and nsla. Oh, we found something interesting folder that is related to sudo script manager. First of all, we will go to the script manager. Oh, wait. Sudo I use script manager. Where am I? No sudo. There must have been typo before. So let's go to the script folder. Why? When you check this folder, interestingly, test.txt file has been modified recently. And when you check the test pi, cat test pi, we can find the test py file, which is owned by the script manager, is related to test.txt file, right? So, and then when you check this again, we can find that the last modified time for test.txt modifies. So the test.txt file that is owned by the root. So when checking the test.py, it's related to test.txt, and the path to root is clear. We are going to replace the contents of test.py with our own Python reverse shell payload. When the root cron job runs our script, it will send us the root shell instead of writing to a text file. As it indicates, the owner of the file test.txt is root, so we'll use echo command to override test.py with our reverse shell, pointing to our new listener. And this will be the command for this. Before that, we will set the listener and using echo command. So I just have changed for the 5555. And after a couple of minutes, the 5555 is directable now, so we can check who am I, this root as expected, and navigate to the home folder and scripts, and we can just like try to see all of this using like this. Oh, there is the root folder, which looks interesting. So root ls cat root.txt. You can also find the root flag. So and we've done it. We have full control of the full root machine. So a fantastic journey from a simple web server enumeration to a web shell to escalating with a sudo misconfiguration and finally routing to machine by hijacking a cron job. The key takeaways here are the importance of through enumeration at every stage and understanding the difference between an interactive TTY shell and a DOM shell. I hope you found this walkthrough useful. If you did, please hit that like button, subscribe for more content, and let me know in the comments if you have any questions regarding this. Thanks for watching.